So our learning targets for today are going to be converting between radical form, where you have the actual radical symbol, and terms that have exponents that are fractions. Another word for the fraction is rational, so you're going to use that word. So we're going to convert between radical and rational exponent form and vice versa. That's the first thing we're going to talk about. Then we're going to review our exponent rules. We kind of touched on that very briefly last time, like when you're multiplying, you add the exponents, when you divide, you subtract them. We have a bunch of different rules that we're going to have to review, and then the rest of our lesson is going to be just simplifying expressions that have those weird rational or fraction exponents. All right, but the first thing we're going to talk about is conversions. So these little P's that you guys have at the top is our conversion kind of rule. So if you guys look at the radical format, you're going to have the index, which I've represented with an N, and then you have the radicand over here, which is an X. Now, for the X, what is the exponent in general when you don't see it? 1. When you don't see an exponent, it's a 1. So our conversion rule, when you guys are taking the radical format and you're turning it into something that has an exponent, what you're going to do is you're going to take the exponent of the variable or term, and that goes in the numerator of the fraction, and the index always goes in the denominator. So whatever the index is in the denominator of the fraction, and the exponent, the original exponent, goes in the numerator. That's our, going back and forth, that's our conversion rule. Okay? So one way to remember, again, I have that written here, the index becomes the denominator, the power becomes the numerator. Right? That's our little rule here. The important detail, an index of 2 is going to be invisible. So you guys have to make sure you're really careful for the square root. Remember how we said the index was a 2, but you can't see it? You have to remember that the index is a 2 for a square root, because if you're going to be converting, you have to make sure that you're using the 2 in the denominator, because that's the index. So you got to be really careful with the square roots. Those are tricky ones. And then another important detail, you may need to simplify the radical or exponent before or after you simplify. We'll see a couple of examples where that happens. But simplification is always present in the process as we're working through these. So this is the key if your exponent is a 1. Let's say you have something that's like squared or cubed or something. If the exponent is not a 1, I've represented it with an M. You can switch M with a number. Again, it could be represented in either of these two formats as a radical, and it would just be the same thing, power over index. Power over index, but the power is a 1. Okay? So power over index, you want to memorize that for yourself. Maybe write it over here as a key. Power over index. That's what your fraction exponent will be when we're converting. Alright, so I have 2 examples right in here for you. One is going from the radical to the rational exponent, and then the other one is the other way around. So here's where I'm starting. Here, is that a 5?
Yeah.
Okay, so I have the 5th root of 2x to the 4th power. Okay, can I simplify that? Okay, so you always check that really quick. I can't simplify that. What's the index for this root? The 5, right? And then what's the power? How did I write 2? Oh, sorry. There are 2 different terms. See how there's a 2 and there's an x? What's the power for the 2? A 1. And then what's the power for the x? A 4. So any term that you have inside the radical, there could be a number or a variable. There could be multiple variables. Each term inside, each piece inside has its own power. So you need to look at each little building block of the radicand, and each one has its own power. So the 2 has an exponent of 1, the x has an exponent of 4. So when I turn it into the rational expression, I'm going to write each of those pieces, the 2 and the x, and I give them each their own little exponent. So remember, it's power over index. The power of 2 was a 1, and the index was 5, so 1/5. The power for the x was a 4, and the index was a 5, so it would be x to the 4/5. Right? So note this looks extremely different from that one. Very different, but that's how you would convert them. Right? So just remember, power over index, and then whatever the pieces are, you can have multiple different pieces. You write them down individually, and they each have their own little power. You'll use this rule to figure out what it is. Okay? As our first little example, we'll practice a little bit more. But let's say we were going the other way around. Let's say I started with x to the 8/6. Can I simplify that? If you saw the fraction 8/6, would that be acceptable to leave it like that? No, we can simplify fractions. So we do that. So if you can't simplify, you would simplify it. So the 8/6 becomes 4/3. Then, now we're going to go the other way around. So if the denominator is 3, what does the denominator tell you again? The index. So if the denominator is 3, that means the index is 3. And then the numerator is 4. What does that tell you? The power that you have. So because the numerator is 4, the power is 4. So if I'm going to convert that, this is going to be a cube root, the index is 3, and this is going to be x to the 4th power because the numerator was a 4. So this is what it would look like. And then, again, this is just a conversion, but if I want to write it fully simplified, you would have to check to see, can I simplify that? And you can, because you can take one group of 3 out with one remaining. So if you can simplify before you do that, if you can simplify after you do that, sometimes it's one or the other or both. Okay? So please make sure you're looking out to make sure that it's fully simplified at the end.
So why wouldn't we simplify in the first example?
Because the 4 is too small, it was the other way around, right? You can't take 5 out of 4. But for this one, you can take 3 out of 4, right? Alright, so I know those first ones a little bit weird, so let's get our hands into it and see if we can do a couple more examples right here. So here's our first one. We have the square root of 7. So the first thing you guys want to do is write down what the index is and what the power is. Okay? What's the index? Abbreviated with an I. It's a square root, so the index is 2, and the power for the 7 is a 1. So when I'm writing the fraction, remember it's power over index, so what would the fraction exponent be? 1/2. What is the component? What's the one component that I have inside of the radicand? So it would be 7 is our base, and then our exponent would be 1/2. So that's the conversion. Right now we're just converting. Okay. All right, this one is very similar to our example that we saw up here. Again, what is the index that we have here?
3.
A 3. Now, how many components do we have to the radicand? 2. So I'm going to have the power of the 2. What's the power of the 2? A 1. And what's the power for the x? A 2. So that means we're going to have 2 different fractions. We're going to have a fraction for the 2 and a fraction for the x. So I'm going to write both of the bases. So I have 2 and then I have x. You can leave a little bit of space in between them so you can write that exponent. So if the power for the 2 is a 1 and the index is 3, 1/3 would be its exponent, 1/3. And then for the x, because the power is a 2 with the index being 3, what would the fraction be for that exponent? 2/3. So that would be the conversion. And nothing simplifies. Okay? Alright, let's keep going. Excuse me. Alright, again, first start by thinking about the index and the power. What's the index? 4. Now notice how there are parentheses here. If there are parentheses, leave them there. We're treating 8x as one thing. We don't have to split the 8 and the x separate from each other because the parentheses are there. It's referring to it as one thing. So we're just going to look at the powers of 8x together as one object. What's the power of that term? 3. Okay? So I'm going to leave the parentheses there like this. And then if the power is 3 and the index is 4, 3/4. Now, I'm perfectly fine with you leaving the answer like this. I'm totally fine with that. That is what I would accept. But just as a forewarning on the SOL, if you were to see something like this, they could either represent the answer like this, or like this. Remember how I warned you guys so much that you can't distribute squares and cubes and stuff like that? Part of the rule is that you can't distribute if there's addition or subtraction inside. If it's a multiplication or division, you can distribute. So what you could do is you can take the 3/4 and distribute it to both of them. So either one of these is perfectly acceptable, but if you want to leave it here for me, for this class, that's fine. I'm just warning you that on the SOL or something, it might look like this instead. Okay? Alright, let's try the next one. What is the index? And what is the power? 4. Alright, cool. So then what is our one component for the radicand? A y? Because again, you can have coefficients, you can have multiple variables. So the one thing that we see inside the radicand is a y. What would the exponent be? 4/5, because it goes power over index. The power is 4, the index is 5, so 4/5. Okay?
So even when
the parentheses and the 4s on the outside, it's never gonna
Correct.
combine with the.
Right, so if you look back up here, right, these two forms mean the same thing. So the exponent can either be inside or outside. They both mean the same. All right, so that was when we started with radicals. Now we're going to switch it around and we're going to start with the exponents and go backwards. Okay? All right, so we have over here, we're going to do the same thing. We're still going to write down what the index and the power would be. All right? What would the index be?
8.
And what would the power be? Which one of these has a power, by the way? The W. So what's the power for the W? 5. Okay, now here's a trick question. There's also a 2 there, right?
That's right.
Is the 2 in any way incorporated with the W that has the exponent that's a fraction? So when I write this as a radical, will the 2 be inside of the radical with the W? No. It's going to be outside. Anything that doesn't actually physically have that fraction exponent has nothing to do with the radical itself, except that it's like a coefficient multiplied at the front. So when you guys write this, you're going to have a 2 in the front. It's not inside the radical because it doesn't have that exponent. That's a fraction, okay? Then you guys can write the radical, right? Sorry, that's the 8. 8th root of what? W is the 5th. Right? Does that make sense? When you have the index is 8, that's obviously the number on the outside, and then the 5, which is the exponent, goes on the inside of the W. But the 2 stays on the outside because it didn't have a fraction exponent. Does that make sense? Okay. Let's try this one. I have y to the 1.2. So this is interesting. This is a decimal. How am I supposed to tell what the numerator and denominator are from a decimal?
I use a trigonometry. So I typed in 0.2 and then you do your answer into enter and it gives you a fraction. So 6 minutes.
Oh, you can also do that by just hitting math 1. But yeah, so whenever you guys have a decimal, you want to turn it into a fraction. So you want to use your calculator, you can type 1.2 and then math 1 turns it into a fraction. So instead of 1.2, what would the equivalent fraction be?
6.
Alright, you need it to look like this in order to do the conversion, so make sure you guys do that. Alright, so then now in this format, what's the index? 5, and then what would the power be?
6.
Okay, so when I write the radical, where would the 5 go? Well, tucked in the corner, right? And then what would I have is the radicand. Now, for all the ones that we did in the top, we couldn't simplify, and then for this one, we couldn't simplify either because we can't take any 8s out of 5. But can I simplify this one? Can you take a 5 out of the 6? Okay, so then make sure you guys use your information from day 1 when we're simplifying radicals to simplify if you can. So because I can take one group of 5 away, you have one y on the outside with 1 left over from the 6. Okay, so then that would be your final answer. Fully simplified. Alright, now this next question is a little bit of a foreshadowing. Has anybody ever worked with negative exponents before? Okay. It is an exponent rule that if it's 4 and 2, you'll be learning it today. You have to make sure that you remember this. Whenever you guys have a negative exponent, what it's going to do is it's going to take whatever your term is that has that exponent, it's going to put it underneath 1. So I'll give you a simpler example. If it was x to the negative 2nd power, this would become 1 over x to the positive 2nd power. So the negative means that this entire term will become positive, but you have to drop it underneath a 1. That's what it means. Okay?
Is it always going to be 1?
Yes. Always under 1. So if I'm taking that same idea for this one right here, the first thing I'm going to do is apply the negative. It's going to be 1 over x to the positive 9/7. So that's how you make it positive, is by dropping it under a 1. So that's the first thing that we're going to do. Excuse me. Then after that, we can do the conversion. So what's the index? 7, and the power? 9, right? So then what would the radical be? 7th root of x to the 9th power, right? Okay, can I simplify that?
Yeah.
Yes, whenever the power is bigger than the index, you can simplify, okay? How many 7s can you take out of 9? 1, with how many left over? So then you have x on the outside and then x squared on the inside. Make sure you continue to write the index. I know you guys are in the habit of just writing the square root without any extra numbers, but if you set an index, make sure you have it in your final answer. So that's what your answer should look like. All right, then we have this one right here. How is this question different than the first one? Question D. Yes. Both terms? Okay, both terms here have that fraction. So does that mean both of these are going to be inside of the radical? Yes. Over here, the 2 wasn't inside of the radical because the 2 didn't have a fraction exponent that matched the index. Over here, now they do both have that fraction exponent with matching indices, so those are both meant to be inside of the radical. You have to make sure you know the difference between those two ideas. All right, so what would the index be? 4. And then I have 2 terms that are going to be inside of the radical. So I have the power for the 2. What's the power for the 2? A 1. And what's the power for the x? 3. So I'm going to write my radical. It has an index of 4. The 2 has a power of 1. How do I write that? It's just 2. And then the x has a power of 3. So one more time, you know that a term is going to be inside of the radical if it has a fraction exponent that matches the index of all the others. If it doesn't have a fraction exponent, that means that it's not involved with the radical. It's going to stay on the outside. Right? And then this can't be simplified, so we're fine with it as is. Does anybody have any questions about the conversions? Next up, this technically involves a calculator, so if you have one, you might want to get it out, or if you need to share with somebody next to you, do that. So this next thing we're going to talk about is how to evaluate an expression or simplify it. So this is going to involve using square roots, cube roots, calculators, stuff like that. So a couple of things to pay attention to. You must simplify any negative exponents first. So if you see that there's a negative exponent, remember that trick. You have to put it underneath a 1. Always do that first. And then you guys can use your calculator to simplify anything that's in the denominator or numerator. And then whenever I ask you to evaluate a radical or an exponent that's a fraction, no decimals. You have to leave it as a fraction if it was a fraction, or a radical if it's a radical. So, well, none of these are radicals, but if it's a fraction, you have to leave it that way, no decimals. Okay? So I'm going to start here. Again, I see no variables, they're just numbers, but I still need to work with this like we were doing before with the conversion and the simplifying. So when I see 0.75, it's 3/4, right? So this is really 16 to the 3/4. Now, the easiest way to do this is to, well, there are 2 ways. I'm going to show you both ways. So the easiest way is probably to put this in your calculator. So if you take your calculator and you type 16, and then the little caret for your power, and then in parentheses, 3/4. And then push enter. You get 8. That's probably the easiest way. Another way that you guys can do it is to actually convert this into a radical. So it would be the 4th root of 16 cubed. So you can find what 16 cubed is and then take the 4th root of that. And you would still get 8. Okay? Either way, once you get it to something that you can actually kind of interpret and use your calculator for, you can, I mean, technically you could probably just have easily done 16 raised to the 0.75 in your calculator. But I still wanted to practice that conversion idea, so that's why I did that extra step. But again, if it's a whole number, you can just stick it in your calculator and you get the whole number. The warning is that if you type this in your calculator and you get a decimal, that means that you can't just use your calculator. You're going to have to use a little bit of brain power to write it as a fraction. So you got to be careful with that. But this one was nice. It turned out to be a whole number. So. All right. Now this one is super blurry. Negative 3.5. Okay. So again, you have to take care of negatives first. If you try to put a negative in your calculator with the fraction, it's going to give you a decimal. Again, we don't want that. So how do we take care of negatives again?
just did the fraction.
So like this, right? And then again, it technically is an optional step, but you can still convert it into a fraction. What would that be? 7 over 2? So you can either write it like this, or you can write it like 9 to the 7/2, right? Now, the way you're going to put this in your calculator, again, I want to keep it as a fraction. Do I already know what 1 is?
Yeah.
1 is 1. Do I know what 9 to the 7/2 is as a number? No. So that's what you got to put in your calculator. Do not do 1 divided by 9 to the 7/2. Just find out what 9 to the 7/2 or 9 to 3.5 is. Yeah. That's what I want your answer to look like. Leave the 1 in the top, figure out what the number in the bottom is, and leave it as a fraction. No decimals. Okay? So whenever you have this negative situation, you have the 1 in the top that stays, just work with the denominator to figure out what that number is. And that would be your answer. Alright? Now this one, whenever I say negative, students are always like, oh, there's a negative, gotta turn it over 1, right? But is the negative in the exponent? No, so don't do that, okay? You only do that flip trick if it's the negatives in the exponent, okay? This is just negative 64. So this one's actually really easy. You can just type this in your calculator. There's no conversions, no simplifying that needs to be done. You're literally just going to type into the calculator negative 64 in parentheses. If I give you parentheses, make sure you include them. So in parentheses, and then raise to 2/3. Make sure 2/3 is in parentheses as well. Otherwise, your calculator is going to think you want to raise it to the second power and then divide that number by 3. No. Should be positive 16. Again, if there are parentheses, include the parentheses around negative 64, and then include parentheses around the 2/3 for your exponent as well. Make sure you're raising it. So in your calculator, it should look like this. You're typing all the keystrokes correctly. Okay, and then you get 16. So if there are no decimals or negatives or anything to work out, no conversions or anything, you can just type it straight in your calculator and give it to you. Okay? Same thing with this one. Type into your calculator exactly as you see it. 2 parentheses 8 raised to the parentheses. Is that 2/3? Okay, 2/3. For some reason I don't have this one in my notes, but yeah, I'm assuming you guys got it. Correct.
Is it okay in yeah, I left the 2 out and then like 2 times.
You did this first and then multiplied it. That's cool. As long as you have them all in there, eventually you get the final answers. Alright, what about this one over here?
Yeah, I need it.
You have to do the inversion over 1 first. So it becomes positive 30, what is that, 3/5? Okay? So then again, the 1 is a 1. Leave that alone. All you guys need to figure out is what 32 to the 3/5 is. Yes. So that becomes 1/8. Again, no decimals, please. If it's a fraction, as you're working, we'll leave it as a fraction when you finish. Okay? Now, these next two are going to be multiplying numbers together that have those fraction exponents. So again, this is going to take into consideration some exponent rules that I'm hoping you guys know already. So when the bases are the same, so the 256 and the 256, right, the bases are the same, what do you do with the exponents when you add them together?
Only them.
If the bases are the same and you're multiplying them, what do you do with the exponents? You add them. It's just like when we multiplied x times x became x squared, because you add the exponents. If the bases are the same, the base remains, it's just the exponents that add. So you want to add 1/2 to 1/4. Well, I know they're different denominators, so you might have to do.
So, wait, are we adding 1 to
You're adding the 1/2 to 1/4. That's really 2/4 to 1/4. 3/4. Guys, remember, the only way you can add fractions is if they have a common denominator, so you might have to convert 1/2 to 2/4. 2/4 plus 1/4. Right? Then once they're combined together, then you can stick that in the calculator. So 256 raised to 3/4 power. 64. Excuse me. right? And then here's the kicker. This one, this time the bases are different and the exponents are the same. For that one.
Just do 5 times
You multiply the bases together. So now you're going to do 5 times 125,
6,
which is 625, and then what happens to the exponent?
so the same.
Stays the same. So it's kind of inverted, right? Whatever's the same stays the same, right? But if it's the bases that are different, those are actually multiplied. If the exponents are different, you add them. I know, it's confusing.
Wait, so for the f, we get 1/2 times 2. Like,
1/2 plus 1/4. When the bases are the same, you add the exponents.
Yeah, so I said
3/4, because 1/2 is the same thing as 2/4. So you have 2/4 plus 1/4, 3/4. You should be able to get that in your calculator, but converting it to a decimal and back in fraction. Alright, so then what's 625 raised to the 1/4? Alright, so all these ones that don't have any variables, they're just numbers, I need you to evaluate them, but you need to be careful in how you're representing the answer. No decimals. Right, now the rest of the lesson is going to be working with simplifying things that have exponents, whether they're fractions or not. Doesn't matter. So I'm just going to review really quickly the exponent rules. You guys should know most of these already, but just to clarify. So again, here's our rule. If the bases are the same and you're multiplying them, you leave the base and you add the exponents. For example, 2 to the 7th times 2 to the 9th, the 2 stays the same, you add the 7 and the 9. Okay? Hopefully everybody's got that. However, if the bases are different and the exponents are the same, you multiply the bases and leave the exponent. So 4 to the 1/2 times 2 to the 1/2, you multiply the 4 and the 2 gets 8, and then the 1/2 stays. So those are just like the examples we just saw. Okay? Then we have this one. If you guys have parentheses with division inside, is there an addition or subtraction in here?
No.
Okay, so if there's no addition or subtraction, you can distribute the power. So if you have division with the power on the outside, you distribute through. So then the m goes to the numerator and the denominator, so you get that result. So for example, x over y to the 4th power is really x to the 4th power over y to the 4th power. Okay? Same thing over here. If you guys have something in parentheses with a power to a power, so if you have a power to a power, they multiply. So power on the inside, power on the outside, those two numbers multiply together. So if you have x to the 4th raised to the 8, 4 times 8 is 32, so the result would be x to the 32nd power. And then just like over here with division, if it's multiplication, again, you can distribute the power as long as it's not addition or subtraction. So when you distribute, you get x to the m, y to the m. So here. And then we already talked about this. If you have the negative exponent, flips to become over, or 1 over, and then it becomes positive. And then just a reminder, when you guys have division with exponents, if you're dividing and they're the same base, the exponents subtract. Okay. So a lot of those I'm sure you guys have seen before. Some of them may be new, but we're going to apply them on the next page. Some of them are easy to work with than others, so you guys really do have to be careful as you're working through. Alright, so our instructions are to write each expression in simplest form. Leave anything that is a radical as a radical if possible. So your guys' default should be to take anything that has a fraction exponent and convert it. Okay, so not only are we simplifying, we're converting. So we're trying to leave as many of these solutions as radicals as possible. Okay? So for example, I have this one right here. Right? You guys want to do this in a very particular order. It's not like PEMDAS. You kind of just have to be smart about it. So anytime you guys have negative exponents, we're going to take care of those. But the first thing you want to do is distribute. Right? You kind of want to work from the outside in. So if you have any distributions to do with the powers, do that first. So that everything's kind of together on the inside. And then once you're in there, you can kind of break it down with the powers. So I distribute the 3/4. The 3/4 distributes to everything. Right? You have two different components. You have the 16 and the y, so you're going to distribute it to both. So the 16 previously had a power of 1, so now it has a power of negative 3/4. The y previously had a power of negative 2. When those multiply, you get positive 3 over 2. Feel free to use your calculator. You can do negative 2 times negative 3/4, get a decimal, turn it to a fraction. There you go. Feel free to use your calculator if you can't kind of do the gymnastics in your head. Now that I'm here, the next thing you want to do is deal with negatives. So distribute first. If you have any negative powers, take care of those next. So I do have a negative power. Remember what happens with that? 1 over, so this would technically become 1 over 16 to the 3/4, but it's being multiplied times this y term, so I'm not going to physically write the 1, I'm just going to take this and drop it underneath. Does that make sense? So because it's 1 times, or 1 over 16 times this, I'm just going to ignore the 1 and just put the y in the top. So it's 1 fraction. So basically, if you have anything that's negative, it just goes to the denominator, okay? So now I'm here. Then, again, like I said in the directions, I don't want any fraction exponents, so you're going to convert. So I converted this, square root of y cubed, and then this turns into a number, just like we practiced on the previous page. If it's no variables, just numbers, turn it into the number, and then I can simplify the top. Simplifies at the very, very end, last time. Okay? So distribute first, take care of any negative powers, do any conversions, and then simplify if you can. So that's the general order of what you want to do.
Can you show us the exponents and then we can why is it there?
Well, we did that at the very beginning, right? What does the denominator tell you? The index. And the numerator tells you the power. So the index would be 2, which makes it a square root, and because the numerator was a 3, the power is 3. And then this one, you can, because it's just numbers, no variables, you just put it in the calculator and get the number. Okay? Alright, jump in. So we have this one first. Oh, why is it so blurry on my screen? Is that 5/6? Okay. Alright, so this is a fraction, and you can't really see very well, but that's a fraction. Alright, what's the first thing I want to do? Distribute. So because there's no addition or subtraction in here, I'm just going to go ahead and distribute. Now, what do you do if you already have a power to a power? You multiply the powers. So in your calculator or in your head, however you want to do it, when I distribute that and multiply those two powers together, not equals. What is the cumulative power when I multiply them together? -5. Feel free to use your calculator. If you need to do 5 over 6 in parentheses times -6 and then turn that into a fraction if need be, or if it's a whole number, feel free to use your calculator. Then you get -5. Okay. Now, once we distribute, the next thing we do is take care of any negatives. Is there any way I can convert this into a radical? Does it have a fraction exponent?
No.
Then it's fine. That's it. Don't leave any fraction exponents. But this one wasn't a fraction, so you're fine. Alright, next one. What do I do first? Okay, so I'm going to distribute to everything. There are two components inside of the parentheses, the x and the y. They both have a power. They're both going to be distributed with the -8. So again, they multiply. So, what is 1/4 times -8? -2. So that's the x component. Then the y. So -8 times -3/2. 12? Positive 12, right? So it's a double negative. Cool. Distribution done. What do you do next?
You put the x in the y.
You take care of any negative exponents. And the way that that works is if it's negative, it's going to drop down. So the y is going to stay on top. And the x goes down. Is there any conversions or simplifying that I can do? No. So you're done. Okay. Next step. What do I do first? How many components are there inside the parentheses? 2. We have the -8 and the x. So both of them get the 1/3 power. What is the current exponent for the -8? Well, 1. So this is going to become -8 to the 1/3. Because if you multiply 1 times 1/3, it stays 1/3. So the 1/3 just attaches itself to the -8 as a power. One of the biggest mistakes that I see with this problem is that you guys forget that 1/3 is an exponent, and when you distribute it, you do -8 times 1/3. 1/3 is a power. It stays as a power. Okay, so leave it kind of up here, superscript kind of notation there. And then when I multiply it times the x term, it's -6 times 1/3. Okay. Now, are there any negative exponents I need to take care of? -2. So this is going to become -8 to the 1/3 power over x to the +2. And then in the top, do I have any variables left? I have variables up here? No, but it is a number that has a fraction exponent. So that's when you guys need to stick it in your calculator and figure out what that is. Now this is -8 raised to the 1/3. So when you type in the calculator, make sure you have the parentheses. So it's -8 as an entire term raised to the 3rd power. What is it? Should be negative.
Wait, you said put an 8.
Parentheses.
So you put
-8.
both in parentheses, right?
Yes. Anytime you're putting a fraction in the calculator, make sure that's in parentheses too. Just so your calculator doesn't get confused. So you get -2 at the top, x squared at the bottom. Can't simplify anything, much it. Yes.
So how do you know when to do the whole like prime index
That's when you're like if a variable has a fraction exponent. If a number has a fraction exponent, you can just stick that in the calculator because the calculator can evaluate. That's evaluate compared to converting. So you can find the value of that as a number. Any questions in the top row? Alright, moving right along. Next one, what do I do first?
Distribute
Okay, how many components do I have inside of the parentheses?
2.
I have the 2 and the y, so I'm going to distribute twice. So 2, what's the power of the 2? 1 when I multiply it times -1. Okay, and then I have y when I distribute the -1 times -3/5. Okay, both of them are negative.
So 1 over 2 over 1st.
So because they're both negative, they're both dropping, but you still have to have something in the numerator. 1. Because it's 2 to the 1st power now, I'm going to ignore the 1. You don't have to write to the 1st power, it's just 2. It's really bad. Alright, now this is kind of what Jada was talking about, or asking about. When you have a fraction exponent with a variable, that's when you have to convert it. Okay, so now we're going to have to go back to the beginning of our lesson. We're going to have to convert this to a radical. Because typically when they ask you to do this problem, they don't want fraction exponents anymore. They want the final answer to be radical. So, what is the index? 5. What is the power? 3. Now, will the 2 be inside of the radical? Why not? The 2 doesn't have a fraction exponent, rational exponent. So it's only going to be the y that's going to be inside the radical. So when I rewrite this, it's going to be 1 over 2 on the outside. And I have my radical. What's the index again? 5. And then y to the 3rd power. And this is what your final answer will look like, because can I simplify this radical? No. Okay. Now, what about this one? What would I do first? What would I do first? Distribute the 8 to both of them. Because there's no addition or subtraction, you can distribute the power to both. Please make sure you guys are writing along with me. Got the sleepy heads in here. Please make sure you're writing along. So 8, again, when you have a power to a power, you have to multiply. So it's going to be a on the top. What's going to be the new exponent if I multiply times 8? Okay, then on the bottom. Alright, now this is interesting. I have the a to the -6. I know that because it's negative, it's going to drop down. But the b's are already down. Going to go up. If it's in a numerator with a negative exponent, it drops down to become positive. If it's already in the denominator with a negative, it goes up to become positive. Okay? So basically, they're going to switch positions and become positive. And that would be your final answer, because there's nothing to simplify, nothing to convert. Alright, what about the next one? Distribute the -1. But I distribute the -1 to the 6. No, because it's not in parentheses. So I'm going to distribute the -1. It's going to, the powers are going to multiply, so it's going to say 6, and then x to the negative 7/9. Okay. Then what? So you distribute first, then you take care of any negative exponents. So this is going to become 1 over x to the positive 7/9. Okay. Now I'm going to go ahead, because it's 6 times this is really 6 over 1, right? I'm going to go ahead and multiply these. So now the 6 is in the numerator, and I have x to the 7/9 in the denominator. So I can go ahead and multiply them together so they're one thing. Alright, now would I leave my answer like this? No, I have to convert. Okay, so what would the index be? And the power? Okay, so I'm going to have 6 over the 9th root of, can I simplify that? Okay, almost done. Any questions on that? Switch colors. Alright, what would I do for this one? Distribute, right? How many components do I have inside of the parentheses? 2. I have the 8 and the x, so they both get distributed, or get the 1/3 distributed to them. So it becomes 8 to the negative 1/3. Remember, if it's a power, it stays a power. Do not multiply 8 times negative 1/3. It's a power, not a constant. So you distribute, and then when I have x, what happens when you raise 15 to the negative 1/3? They multiply, right? So negative 5. Okay. Now what? Take care of any negative exponents. They both drop, right? So they're both negative, but you still need something in the numerator. It's going to be a 1. So it drops to become 8, 1 to the 1/3, and x to the 5th. Is there anything I could touch up? Is this a number that I could find? 8 to the 1/3. Anything that has a fraction exponent, the fraction exponent cannot stay there. If it's a number to a fraction exponent, you're just going to evaluate it in your calculator. So you can use your calculator to figure out what 8 to the 1/3 is. 2. So this is going to be 1 over 2 x to the 3rd power. Okay? Now, I'm going to let you guys do the last two by yourself. See if you can figure it out. Now, I just want to talk about this one a little bit. It's a little bit mean. This is a slightly mean one. Now, I know how when we were doing the process, I did say the first thing you guys want to do is distribute, which you still can, perfectly fine. But one thing you guys can actually do to make this a little bit easier for yourself is to simplify the 16 over 20 before you start. You don't have to. You can do that within the process of the problem. It just means you'll have slightly different numbers to be working with in the process, but if at the beginning you see that you can cancel out or divide the 16 over 20 to simplify that fraction, it might make the numbers a little bit easier to work with. So if you did that, what could I divide out of both 16 and 20? A 4, right? So this would really become a 4, and this would become a 5. Smaller numbers easier to work with. So again, when you guys are working through this question, you distribute, so it becomes 4 to the negative 1/2 power, and then z to the negative 1/2 over 5 to the negative 1/2 power, and then x to the negative 4 when you distribute everything. Because everything's negative, essentially both the top and the bottom have to switch. Whatever's on the bottom goes to the top, top goes to the bottom. And then we would have 5 to the positive 1/2, x to the 4th, and then 4 to the positive 1/2, z squared. Now, 4 to the 1/2, you guys can put that in your calculator really easily. That's 2. That's where the 2 came from, 2z squared. But when you guys put 5 to the 1/2 in your calculator, did you get a whole number? Remember how I said no decimals? Okay, so if that doesn't work for you, that means that this wasn't a perfect power, wasn't a perfect root. So if that happens, if you guys try to evaluate a number and it's a decimal and it's not allowed, convert instead. So remember with the fraction, the denominator is the index and the power is the numerator. So that just means that it's the square root of 5 to the first power, square root of 5. Okay, so whenever you try to do that evaluation with the number with the fraction exponent, you get a decimal, convert instead of giving me that decimal. You convert it to a radical. Okay, so that's how you get the solution for that one. You'll get the same answer if you guys leave the 16 and the 20. It just means that when you guys take the square root of 20, you would have to simplify it, and then you would cancel that, the square root of 16. It would cancel out. So just be aware of that. And then hopefully everybody got this one okay. Distribute the 2/3 to 1, 2, 3 different things. Everybody okay with that one?